Let us now study about ammonia with a chemical formula being NH3. We all know that it is a compound of nitrogen and hydrogen. So first and foremost, where all can we look for ammonia? Well, in its natural state, ammonia is naturally found in soil as well as in air. And where does it come from? It comes from animal urea, from their death, from death of plants, and the fungi and bacteria decay all these things and give us ammonia. And if you see here, nitrifying bacteria converts this ammonia back into nitrates in the soil, and the nitrogen cycle goes on, right? This was about natural occurrence of ammonia. How about preparation of ammonia? When ammonium salts are decomposed with the help of calcium hydroxide, ammonia gas is what we get, and by downward displacement of this gas, we collect ammonia. This is the small scale or laboratory preparation of ammonia. How do we prepare ammonia on large scale, industrially? So nitrogen and hydrogen are taken from the air, obviously in the ratio 1:3 by volume, right? At a temperature of 400 to 450 degrees Celsius, pressure is maintained at 200 atmosphere, and iron is used as a catalyst, and these gases are cooled and turns into liquid. Liquid ammonia is what we get. Any guesses what this process is called? It is the Haber's process, right? So ammonia is a colorless gas, has a pungent odor, and its boiling point is 198.4 kelvins. This is how ammonia looks like. It has a tetrahedral geometry. It has one lone pair of electrons, right? Ammonia is a water-soluble compound, right? And it reacts with copper ions to form a deep blue solution of copper nitrate, and it reacts with almost all the ions, metal ions. Reason being, it has a lone pair of electrons, so these positive ions get attracted to those lone pair of electrons, and this reaction helps in detection of metal ions in a solution, right? Well, sulfates of ammonia are used as fertilizers for plants. You must have heard of nitrogen fertilizers. Here we see ammonia being used as a refrigerant. So, ammonia has a very low latent heat of vaporization. So, to convert into vapors, it needs a lot of heat energy, and it absorbs this heat energy from nowhere else but its surroundings. And when the surroundings, when this heat energy is taken away from surroundings, of course, surroundings get cold, right? And hence, ammonia is a very suitable material for refrigeration in our ACs and refrigerators. However, ammonia is poisonous in nature, and if it leaks out of the condensers, it might be harmful. So these days chlorofluorocarbons or CFCs are being used as refrigerations. These CFCs are quite harmful to the environment and are costlier. So here we have the production of nitric acid with the help of Ostwald's process. With the help of Ostwald's process, ammonia is the primary chemical used to prepare nitric acid, and nitric acid further is used in lot of chemical reactions. Alright, so time for a couple of questions now. Why is ammonia used as a refrigerant?